would like to share with you another example. We can analyze a circuit with diodes without doing any calculation. So before starting to analyze this circuit, I would like to tell you that the direction of my analysis is of course not the only direction that exists. So with practice everyone can have his only direction, but at the end we would lead all to the same result. Now let me, just to make the analysis of this circuit easier, I will draw it in another way. So here I have 0 volts, I have 5 volts, here I have 4 volts. Now I can draw this circuit in this way. So I can say that in this point I have 4 volts, which will drop of course across a resistor R1. Here I have a diode D1. This is a node, and after this node I have a resistance R2. So let me draw it with the other convention like this. So this is R2, and in this node is connected to the diode D2, whose anode is connected to a potential of 5 volts. So let's start the analysis of this circuit. So I would like to start by assuming that D2 is blocked. So I will assume that this diode here is blocked. So in this case the current the current in this case current will flow in this direction. Excuse me. The current will flow in this direction from the highest potential to the smallest potential, which is 0 volt. In other words, the voltage in the B, let me call this point B, the voltage in this point would be smaller than 4 volts, because the flow of current across in D1 would have dropped this potential to a value smaller than 4 volts. But now I can see that this is something illogical, because just let me connect again this diode to this node. So in this case, if D1 is conducting, then D2 cannot be blocked, because the potential across D2 should be higher than 1 volt, right? So let me explain this point. So VD2 is equal to 5 volts minus VB. I know that VB is smaller than 4 volts. This is equivalent to minus VB, higher than minus 4 volts. So if I had here 5 volts and I add here 5 volts, this would lead to VD2 higher than 1 volts. And since VD2 is higher than 1 volts, this means that VD2, the potential across the diode, is higher than 0.7 volts, right? In other words, D2 has to conduct if D1 is conducting. So now I know that if D1 equal 1, D2 has to conduct. Now, what's going to happen if I assume that D1 is not conducting? Will D2 conduct? Of course, yes, because the current has to pass from the highest potential to the smallest potential. So the only way to pass from the highest potential to the smallest potential is through D2. So the current has to pass from 5 volts point to this point, which means that D2 is going to be conducting. So now I know that D2 equal 1 no matter the state of D1. Let me denote no matter the state of D1 by this expression, right? So what I conclude from this is that D2 is going to conduct definitely without any doubt. So D2 is equal to 1. Now what I don't know is whether D1 will conduct or not, or no. So how can I determine if D1 is going to conduct? So this is very simple. Now, if when D2 conducts, then the voltage in the point B, the voltage in the point B will be equal to 4.7 volts, right? But if this is the case, this means that the voltage from between the point B and the point A, let me call this point A. So this means that VAB is smaller than 0, right? 4 volts minus 4.7, oh sorry, so this is 4.3 volts. So if this is the case, VAB has to be smaller than 0. In other words, the current, this voltage will force the current to pass from the point B to the point A. But this is impossible because D1 will oppose the flow of current from the point B to the point A. So from this I can conclude that D1 is going to be reverse biased. So D1 is reverse biased means that D1 is blocked, right? Because the current cannot pass from the point B to the point A. The current can only pass from the point A to the point B. So now I know that D1 is going to conduct definitely, and I know that D2 is going to conduct definitely no matter the state of D1, and if when D2 conducts, I concluded that the diode 1 does not conduct. So in this way, we would have established the state of the two diodes without doing any calculation.